Hi everyone, my name is George Semaganda and kindly subscribe to my YouTube channel, the link below. I'm here to address a problem that is basically faced with farmers, and then we shall see how we can use machine learning to address the problem. Our solution is AgriGeoSustain, as you've seen. Then what is AgriGeoSustain in a nutshell? So AgriGeoSustain leverages geospatial data to enhance Ugandan agriculture. So our solution promotes sustainability, increases crop yield, and optimizes resource management. So we aim to boost food security and economic growth through data-driven agricultural practices. So with a brief hint, then we can look at the problem we are trying to solve. So here is a problem. Uganda faces challenges in achieving agricultural sustainability, food security, and economic development is still an issue here in a country where we have rich soils and seasons full of rains and whatsoever. So the inadequate resource management and climatic variability impacts crop yields and livelihoods of almost everyone. So our geospatial data can provide insights to address these issues and foster a resilient agricultural ecosystem. So if now we know the problem and the solution we are trying to build on, now I want to explain machine learning and how basic we can use machine learning to address this problem. So if we continue, we are going to look at machine learning, an introduction to machine learning, and then the various types of machine learning. Then we shall look at the feasibility and then where to apply what model and when you get it. So machine learning is a transformative technology which we can integrate to our project AgriGeoSustain. So it will enable us to harness the power of data from informed decision making in agriculture, driving sustainable practices. Yeah, and that makes sense. This point clear. It makes sense. So its significance here, we look at machine learning can empower the AgriGeoSustain to process vast data sets, providing actionable insights. So it plays a pivotal role in optimizing resource use, adapting to climate changes, and enhancing market access for farmers. So yes, and then we need to understand the various types, the paradigms we can look at here for our problem, and then our solution we are providing to the farmers. So let's we have three paradigms we are going to look at. We shall look at the supervised, the unsupervised, and then the reinforced. And how are all these different from one another? Let's look at supervised. Learns from labeled training data sets. Yeah, if you can, I want us to differentiate between like the supervised amongst these three: the supervised, the unsupervised, and then the reinforced. So you see here labeled data training data sets. So we have data we are learning from, and then maybe we have a picture of the output we expect in case our model is deployed and it's running somewhere. So the applicability of this, we can look at the models, and then the problem types, and then the utilization of labeled data using historical data sets for this. If we continue to unsupervised, we extract patterns and relationships from unlabeled data sets. Here it will employ us to use clusters because maybe we are going to be dealing with the data sets that are too big and wide. So you find that amongst the techniques we need for supervised learning is clustering, and then the dimensionality reduction. Then the patterns, we can discover hidden patterns in crop distributions, then and weather conditions, weather forecasts. So how do we handle this? We extract meaningful information without historic labels. So if you continue to the reinforced learning, it's basically does its works through interaction with an environment. It's so dynamic in such a way that it's so dynamic and it's so flexible, if I may say so. For example, training an agent to navigate a field and optimize crop planting. So an agent, you deploy an agent, you need to deploy an agent. It goes through a field and probably find out how wide the field is. Then it will have the dimensions of head, how the separation you need to put between the crops as you're planting for the best yield, and then it will maybe give you a hint of the expected yield at the end of the season. So how do we integrate it with our AgriGeoSustain system? So if you look at the environment, that can be the agricultural field that has varying weather conditions, physical conditions, everything. So an agent who can maybe look at any smart equipment, for example, a drone can do it faster for us, and then the reward, how are we benefiting? We get optimized resource usage and then increased yield at the end of the day. So potential use cases, you look at dynamic decision making before irrigation, decision making at the beginning of season, and decision making at the end of the season. So then crop rotation you get. So there are so very many ways we can benefit out of this. So if we compare our comparative analysis, we compare these and how are they different. We can briefly look at supervised that uses historical labeled data, which is different from unsupervised that uses unlabeled data for historical insights, and then the reinforced that is dynamic in an evolving environment. So the three of them, they are different in some way or another. So preferred, what should we prefer at any time t? We can prefer supervised, maybe for specific predictions, then unsupervised, so broader patterns, and then reinforcement for adaptive real-time decision making. So then case studies and use cases. If you look at the use cases where we can employ these models, if you look at supervised learning, yes, crop prediction based on historical data, it can give you accurate prediction, the crop type and yields at the end of the season. Then the unsupervised can help us identifying regional patterns in crop description, so you can see hidden correlations for targeted interventions as one of the expected outcomes. So for reinforcement, the use case is dynamic. There's always dynamic irrigation optimization, so look at maybe the outcome, real-time adaptation to weather changes, and then resource efficiency at the end of the day, if we add them together. So yes, we're coming up with a solution to a problem under machine learning, but still we can't say it's just a gradual shift. Okay, it can be a gradual shift, but at some point we expect it to consider challenges, and maybe the challenges, how are we ready to mitigate them, to overcome them? Those are the considerations we can look at here. So amongst the challenges, we have navigating data quality challenges, okay, the variability, accuracy, volume of the data since we are dealing with bigger data sets here. Then computational resource management, scalability, as the system scales, what do we expect? Then the infrastructure, then processing speed, you get. Yeah, so we have to put all this into consideration as we come up with our system. Then ethical considerations and bias mitigation, fairness, ensuring transparency, and then sensitive agricultural data through the machine learning cycle. As we conclude, the impact of research, yes. Thank you so much. Yes, thank you so much. Thank you so much.